Welcome to Finding the Missing Side Part 2. You will notice I'm in a new studio now. I'm at home, so hopefully this still works as well. My board's a bit smaller, so we'll see how we go. If you've been in any of my real lessons, you'll know that I like to do a bit of a warm-up at the beginning, and so I've got a bit of a warm-up for you today. The first thing I just want you to do is to remember something, is that when we've got a fraction, the number on the top is called the numerator, and the number on the bottom is called the denominator. It's worth writing that down. My second thing I'd like you to consider is whether tan 40 degrees equals x on 10 is the same as tan 40 degrees equals 10 on x. Now you can pause and think about that, but hopefully you can see that those two things are not the same, and we're going to be using that concept later this lesson. The second thing I want us to do as our warm-up is just to remember what we did in Finding a Missing Side Part 1. So when we had a question like this and we had to find a missing side, in this case we had to find this side here, the first thing we did was to label our sides. Now from the angle we decided that this one was the adjacent and that this one, the one we wanted to know, was the opposite. Then we used our SOHCAHTOA, S-O-H-C-A-H-T-O-A, with the O and the A, we decided this was a tan question. So the second thing we did was decide on which of our trig ratios it was, and then we solved the questions showing all our working out. So we said that tan of 40 degrees was equal to the opposite over the adjacent, so that was x over 10. We did our little bit of algebra where we times by 10 times by 10, and we end up with 10 tan 40 degrees equals x. We put that into our calculators and ended up with 8.39 metres because we were finding a length. So that's what we did last lesson, and just notice that in this solution, x, when we had our solution here, x was the numerator. It was the number on top when we solved that question. You can probably see where we're going with this. You probably need to write that down, so pause the video. When you're ready, come back, and then we're going to move on to the actual part 2 for finding a missing side. So I've got 3 examples here, and we're going to do exactly the same as we did the first time. We're going to label the sides. So in this question here, the side that I've got here, the one I'm interested in finding, is the adjacent. It's next to that angle. And this side over here is the opposite. It's opposite the angle we know. We're going to identify which ratio to use, and because I've got O and A, it's going to be a tan question, so I'm going to say that this is a tan question. So I will write tan of 42 degrees is equal to the opposite over the adjacent. Now the opposite is 14 and the adjacent is x. Now this is the difference between last time, because now our x is the denominator, and the way we solve this, the way we do our little bit of algebra, is a bit different. Now, if this algebra is starting to look tricky, please don't switch off, because it's going to get easier. We're going to find a little cheat, a little way to cheat here. So let me just do the algebra this time through. I'm going to times both sides of this equation by x, which will give me x tan 42 degrees is equal to 14. And then I'm going to divide both sides of this equation by tan of 42 degrees, divided by tan of 42 degrees. So I end up with x is equal to 14. Now remember, division is just like doing a fraction, so I'm going to write it like this, over tan of 42 degrees. Now I know what to put in my calculator, so I'm going to put that into the calculator. You might pause and do it on your calculator. And I end up with 20.92, and this question was in metres, so the missing side is 20.92 metres. Now I'm going to do the second question in exactly the same way. You might pause and do it by yourself, and then we'll do question 3 with our cheat. And let's do question 2 the same way. You can have a go by yourself if you like. So from our angle here, this time we've got the adjacent, it's next to that, and we've got the hypotenuse. So this is an AH question. When I go up to my SOHCAHTOA, A and H are together here with the big C for cos. So this is a cos question. So I'm going to write cos of 38 degrees is equal to the adjacent, which is 20, over the hypotenuse, which is x. So we've got x as our denominator. I'm going to do my algebra. I'm going to multiply both sides by x, which gives me x cos 38 degrees equals 20. I'm going to divide both sides by cos 38 degrees. Remember, this is going to get easier. Giving me x equals 20 over cos 38 degrees. Grab your calculator, do your answer. I've got 25.38 metres. Now, before we go on to the third one, let's see if we can work out a quick way of doing these. A little bit of a cheat. You'll notice here, I'm going to change my colours. My first line of working out was this one, tan 42 equals 14 over x. But by the time I'd done my algebra, I had x equals 14 over tan 42. In the second question, my original statement was that cos of 38 was equal to 20 over x, but by the time I was putting it into my calculator, I had this. Now, can you see that between here and here, what's happened is that the x and the tan 42 have just swapped position. So if we can see that whenever we solve these, the same thing happened here, the x and the cos 38 have just swapped position. If we can see that that pattern happens, we don't have to do all this algebra every single time. So let's try the third one. We've got our angle here. I dropped the red pen. We've got our angle here. We're interested in the adjacent, and we've got the opposite over here. So O and A is going to be a tan question. So my working out will be tan of 20 degrees is equal to the opposite, which is 8, over the adjacent, which is x. I can use my cheat now. I can say the x is on the bottom, or x is the denominator, so I can just swap the position of those two things. So my next line can just be x equals 8 over tan of 20 degrees. Put that into your calculator. .98 metres. So that is a lot quicker than having to do all the algebra. You can do all the algebra, but you don't have to. Now, this cheat only works when x is the denominator. And in your textbook questions that you start off with, you'll probably have all the questions where x is the denominator, but later on we're going to mix it up, and sometimes x will be the numerator, sometimes x will be the denominator, so you need to know how to deal with it as we go. But this is what we can do if x is the denominator. So perhaps at the bottom we should write something like that. When x is the denominator, let's write that here. When x is the denominator, that means it's on the bottom of the fraction, we can swap it with the sine, cos, or tan value, whichever question it ends up being. All right, try some of those questions by yourself, and I look forward to seeing you next time.